Hi guys, welcome back. It's Nick here with another episode of the Transport Game in Unity 5 series. I think we're up to this is episode 26 now, so doing pretty well with this. So in the last episode we were looking at, let me just grab the scene, we're looking at creating a sort of inventory system within our world. So we created our storage script and just implemented some basic functions and got some items running in the game. So what I'd like to do this time around is create the idea of a factory system, really basic, just so we can start seeing items flowing in and out of these inventories and how the game's going to be fleshed out basically. So yeah, I'm going to get started. So I'm not going to continue on the storage script for now. We got, I think, far enough with it. So I'm going to go back into Unity. I'm going to create two new scripts, one of which I'm going to call factory. And this is going to be what we put on our factories in the world. And this is going to handle all of our world objects, clicks, or all that kind of thing, and just interface with the player. I'm also going to create another script, and I'm going to call that factory data. Now, the idea of this is I'm going to use the Unity system called scriptable objects, which will allow us to create a generic factory type with a load of methods and variables, which can then be accessed from our factory script and manipulated. So in the world, we'll only have to define the factory type coal mine once, and we'll just drag that data in the inspector onto our factory script, which will say, hey, I'm a coal mine, and it will do all that stuff. So it should be really simple. So I'm just going to double click and open these up in Visual Studio. Okay, I'm going to start with the factory data object. So because it's going to be a scriptable object, we've got to convert the inheritance so it starts off being from the mono behavior type. So just change this to scriptable object. Ta-da! And there we go. And there's a few other magic tricks you have to do to make scriptable objects work properly, in my opinion, in the inspector. So the first thing you got to do is just whack on a create asset menu, and this is really needed if you want to make a lot of these, as it's the way you're going to create the objects in the project library that you can drag into the world. So I'm going to call it menu name equals factory. There we go. I'm just going to delete these start and update functions. Okay, so if I go back to Unity, just recompile. So this is now factory data is now a scriptable object, and you'll find that if I go to assets, create, I've got factory up here. So I can create a new factory, and I can call this coal mine, for example, and that's our object in the world. I'm just going to create a new folder to put that in, actually, called scriptable objects. Put that at the project root, just a bit of housekeeping really. And factories. Okay, there we go. So that's our first type of factory. But you'll notice it hasn't got any properties on it because we haven't made any. So the first property I'm going to put on here is going to be to do with the objects this factory creates. So it's going to have a list of items that it produces, and also a list of items that it requires to make the other items. So to do this, I'm going to make a new struct, and I'm just going to call this production data, put that in, and I'm just going to put a public item type, and I'm going to call that target item, and that's the item we want to make. And I'm going to put a public int count, which is, or actually I'll call that amount. So this is the item we're going to make with this factory. So for a coal mine, this is probably going to be coal. Actually, do you know what I'm going to do? I'm going to use the item pair from our storage script. So in our storage script, we have this struct item, which is an item type and account. I'm going to reuse that. So I'm going to make this just a target item, which already has the item type and count included in it. And I'm also going to have a public array of item like this, which is going to be required items. And this is going to be optional, so not every factory is going to require some items to make its items. So for example, a coal mine doesn't need any items to make coal. It can just get it from the world. Let's say our paper, which was one of our other items from last time. So to make paper, you're going to need some wood. So we're going to put some wood in there and say, this factory makes paper, but to do that, it needs wood. So super simple, just a list of items. And the last thing we're going to do is a public float, which is required time. And that's just how long it takes to make the item. So we've got our data struct. I'm just going to fill in these comments. Right, and then our factory is going to have a list of these production datas on it. So I'm going to do a public production data and I'm going to call that productions. There we go, just like that. Whoops, seems like I missed the public of this struct. There we go. Actually, this shouldn't even be in here. My bad. I'll just put the struct outside of the class. Just leave that production data outside there. So this isn't happy. Oh, I've just misspelled it up here, so I'll just copy that. There we go. So it's spelled the same now. Everyone's happy. So let's check that all works. So let that recompile. And then let's have a look at coal mine. We haven't actually got any data on here, so let's have a look back in our script and see why that might be. Okay, so I know why this is. So to make these structs accessible in the editor, we're going to have to add the system.serializable to it, just so the Unity knows to put this out on the screen and to serialize that struct. There we go. So now we've got that serializable tag. The Unity knows to put that struct into the editor, and we've got this array. So if I make the coal mine array 1, I see we've got the same problem again. So these items that we made aren't showing up. So again, we want to grab this serializable tag, and copy it across to storage right here, system.serializable, and then recompile. So we should get our items now. Target item, yeah, perfect. So we'll just set that to say wood and count to 10. However, we're still missing our list of other items. Let's just check why that might be. Oh, I see. I just commented that out for a debug. Okay, there we go. So we've got our required items, which is going to be 0 for this, and our target item, which is going to be coal, and we'll just set this count to 10. Required time, say 10 seconds to make some coal. Brilliant. So this is our raw data, so this is what's going to drive the whole game. And now what we want to do is create a script to plug this into that just runs our whole factory for us. And that's what's going to be our factory script. So I'm just going to delete the default functions to start with. And I'm going to add a require component tag, because it doesn't really make sense to have a factory if it doesn't have a storage, somewhere to keep its items. So I'm going to add storage to that. Sorry, this should be type of storage, because this takes a type. There we go. So we got require component storage, and I'm also going to add a public factory data, and I'm going to call this factory type. There we go. And if we jump back into Unity, you see that this, when this recompiles, when we drag this onto say a new cube, there we go, we've got our factory type, which we can drag coal mine into, and now we've defined our factory. And because we've got a storage here, everything's happy. But if I were to make, say, a new cube without a storage on it and try and add a factory, because we've added the require component tag, the storage script is automatically added, which is brilliant. So we'll just drop the command line on this. Well, actually, we'll use our original one. There we go. Okay. So we've got our factory data now to sort of start ticking it. So I'm going to re-add our update function. And the first thing we want to do is just tick through our factory data and see if we can produce any of the items. So I'm going to say for int I equals 0, I is less than factory type dot productions dot length I plus plus. So we want to iterate over our factory type productions, and then we want to check whether we have any of the prerequisites to do that. So we want to do that with our storage. So I'm going to do a private storage, and that's going to be called M storage, which is going to be my storage. And that's just going to be a reference to the storage script. And we'll initialize that in awake. So I'll go M storage equals get component of type storage. There we go, like that. And we should have our storage script. So now we can query the storage and see if we have enough items to make any of these productions. So I'm going to add a new function specifically for that purpose called bool check. So check requirements, which is going to take a production data as the production, like that. And that's going to check to see if we have all of the items to make that production. So we're going to go looping through all of the requirements. Required items.length. And then we want to say storage or M storage dot get items. What did I call that actually? What was it called? Add item, get item. Actually, these need to be public. Public item, get item. And public void add item. And public void remove item, which we haven't actually filled in yet. But we'll leave that for now. So we want to call mstorage.getItem, and we're going to pass in production.requiredItems at I.type. And what that's going to do is it's going to give us a reference back to an item object. Otherwise it's going to return item type none, which has 0 count. So I'm going to store that off in an item object, it's called mitem. And the thing we want to check here is, do we have more than the required amount? So and sort of by checking this, we want to check if we don't have the required amount and fail rather than check if we do. So the way we do that is we just say if mitem.count is less than the required count, like this, just to return false. And then at the end, return true. So what this means, if we've reached the end of this function and we haven't returned false yet, it means we definitely have all of the items we need, so we return true. So I'm going to use that just up here and do if check requirements for factory type productions I, then we can make this item. I'm just going to do void produce item, and I'm just going to pass in a production. And that's going to handle giving the item out. So I'm going to call produce item just like that. There we go. So we've got our productions. We can produce the item, which involves just giving the player this item. So we're just going to say removing all of the requirements. So I'm just going to copy required items, the loop from just above here, and we're going to remove all of the items that we required. So mstorage.remove item, and that takes a type and an amount. So we'll just pass in those. In fact, do you know what? I'll be even more efficient here by just adding an overloaded version called public void. Actually, do you know what? I won't do that for now. I'm just going to change this from being a type and account to just an item. I know this isn't filled in yet, so we can make these kind of changes. Because remember, our item is just an item and account from up here. It's just a type and account. So we don't need to reference them separately. And that means over here we can simply pass in our factory production.required items at I, and that will remove them all. And then we say mstorage.add item, and the item is production.target item, and that will give us some of the stuff. Okay. So to test this, because we haven't really got any graphics, what I'm going to do is put a debug log into the storage script. So I'm going to add debug.log. I'm going to say got item, and then add on new item dot type. So it's just going to say, hey, we got a new item here, which is cool. So let's test to see if that compiles and works. It compiled. So let's put this to the test. So we've got our coal mine already set up with 10 coal. Let's see what we get in game. Okay, we're playing. We've got a message down here, got item top coal. There's loads of them. So what's happening here is every frame we're getting loads of coal. It's because we haven't got any cooldown on our coal effect. It's just saying every frame give them a coal, which isn't right. So we're just going to quickly fix that. And the way we're going to do that is in the check requirements function, we're going to add a new check against time. So I'm going to say create a new private value within the factory data. It's going to be a float, and it's going to be called last update time. And this is the time that we last got some items from this. And then we're going to use that data back in our factory script. So in produce item, when we get it, we want to update the production. So production dot see, I made that private, which was a mistake. So this value needs to be hidden from the inspector, but viewable in code. So I need to make this public and add the tag hide in inspector, which will solve that problem for us. So this is a public value, but the inspector's going to just skip it. Don't show the user, because we don't want people messing around with this. So now we've made that public, we can set it in our factory script. So last update time equals time.time, which is just the time in seconds at the current in the current game. So we're going to check this in the check requirements function and just say if you've not waited long enough, return false, don't get the item. So the way we do that is you compare using if time.time, which is the current game time, and see if that is less than the production.last update time plus production.required time. And if that's the case, then we haven't waited long enough, so we want to say return false. And that should mean we only get coal every now and then. So let's just check if that works. So clear out the console so we can see what's going on. Make this a bit smaller so we can see the game as well. Hit play. So we should wait 10 seconds and see the log got item coal. We're not actually seeing anything, we're just seeing loads of stuff now. So this isn't quite right.
2,000 years later.
Okay, so I've done some debugging and found out what the problem is. So what I'd forgotten with these functions is they pass in production data, but we don't want to actually create a new production data when we call this function. We want to actually reference back to our productions array in our factory type. So the way you do that in C# is just put the ref keyword, and that means you pass the value by reference, and any changes you make within this function are going to affect the base data. So I just put the ref keyword up here as well. So there we go, we've passed by reference, so all of these should work out okay now. The other way to fix that problem is to move our functions onto the scriptable object itself, which could help us in future, but for now I'll just fix it this way. So we play the game, wait a second, get item coal, there we go, so we've got our timer, and you get coal every second. So super simple, but this is like the core gameplay, and having this in is going to shape the rest of our decisions. So what I'm going to do next time is start introducing the idea of routes and splines, so we can start connecting up these factories and have them interacting with one another, which is another really key part of gameplay. So thank you very much for watching. I've been Nick Pearson, and I'll see you in the next episode.